Starting recording. All right, so in this particular figure, it's a pretty common figure. Like, I don't know that I'll get a whole lot more. I don't know, we'll see. This is a pretty good like benchmark to know if you're in good shape or not. There are a bunch of different things you should be able to tell me about this. I tried to include the three main things you need to know, which we said there's sort of a process for going through and solving for things when we do triangles, based on what we learned the other day. First, though, let's just talk about some of the easy stuff. What do we know about this figure? Lucas.
Angles 1, 2, and 3 make a triangle.
So if you were not here, so Chaz, I know you weren't here. If anybody else was that figure out. We learned a sort of new, you've actually learned it before. We said the three interior, that is a key. They have to be interior, inside the triangle. So if you'll notice, everyone I'm circling is inside that triangle. The three angles of a triangle have to add up to 180 degrees. Now, we'll get to this probably when we start doing stuff with the sides of triangles. This has nothing to do with the sides of the triangles. For some reason, kids get confused when we start talking about the sides of triangles and they think they have to somehow add up to 180 degrees. This is about the measure of angles. We measure angles in degrees. We use this little tool here, a protractor, and we put it on there, and then we say, okay, well, that angle is bigger than 90, certainly, so it's a 125 degree angle, whatever it comes out to be. That has nothing to do with the length of the sides. So this is totally separate from the length of the sides. So make that note. If you at all don't understand that, you need to make that note. Every year, a bunch of kids make that mistake when we get into doing something with the sides, and they start using the 180 degrees. 180 degrees has nothing to do with the length of sides. Nothing at all. I can have two triangles and they all have the same measures of the angles, but one's a gigantic triangle and one's a teeny tiny triangle. It has nothing to do with the sides, the measure of the angles. And if you think about that, if you like zoom in or out of a triangle, the sides get bigger or smaller, the angle sizes do not change. You like had a picture of a triangle on your phone and you zoomed in out. What else do we know? That's certainly one of the main things. I'm going to skip Lucas, somebody else. No volunteers? I'm just going to start asking. And the early questions are the easy ones. Andrew, what else do we know? The 1 plus 2 plus 3 is 180 degrees. That's one thing. Not 4 and 3. 4 is not congruent to 3. There's something about 4 and 3 or 4 in another angle. So if we see, so here's one of the things I said look for in figures. You see an X somewhere in the figure. Well, there's an X right there. Two lines cross and keep going. That means we have vertical angles. So we said when there are vertical angles, the angles across from each other are congruent. So those two angles are congruent to each other, and then these two are congruent to each other. The number of, I call them tick marks. I think the official name is their congruence marks. The number of markings, though, tells you which ones are equal to each other. So these both have 1. I'm going to do them in this it won't be in different colors in your, well, actually in their book, sometimes it is. On a test I make, it won't be in different colors though, because I can't copy in color. So it'll just be the number of marks. So if they have the same number of markings, then they have the same measure. So in this case, we could say, well, 4 and 6 are congruent. They have the same markings. They're congruent because they're vertical angles. And then we show that by putting the same markings. What else do we know? Any other volunteer?
All right,
Ernesto. Well, there's a volunteer there. So Neo beat you to the punch. Again, wherever the X is, there's 2 pair of congruents. It's not just 1 pair. So if these are congruent, those have to also be congruent. 3 and 5. Oh, you already have yours. Ernesto, give me another thing. But yes, I believe you're going to. We'll see if Ernesto uses what you're just. So I'm gonna get rid of that. So again, look for an X. This is the order I told you to go in, by the way. Look first of all, well, actually, no, we're kind of jumping around. I think they're back. I said, look for that X first and see if you have vertical angles.
Bless you. Sorry.
Then there's another thing I said to do next, which maybe Ernesto remembers, or maybe he doesn't. Was it? He said, no, I don't. But you can still tell me some other stuff. There's still some other stuff. One was a new one we learned last week. And then one's not new. One's we've used many, many times before. We used it in proofs. We used it when we first started with angles. No idea? You guys have all answered. Javier, what about you? Got anything for me? What do you know about this figure? Anything else you can tell me? Anything else you can tell me? This figure, the angles in this figure.
It's like a triangle, but
What can you tell me about the angles? Like specifically, what about the angles? Well, we went over that. So 1 + 2 + 3 is 180. I'll take that. Corinne, anything new you can tell me? Perfect. So here's the other thing I said to look for. Javier. Trying to keep you in here today. See how that goes. So we said if you have two angles that are adjacent, so they're right next to each other, we can draw a semicircle through both of them, and it could actually be at 3 angles. In this case, it's 2. Those 2 angles have to add up to 180 because they're sitting on this same straight line. This straight line is 180 degrees. All we did is just divide that angle into 2 smaller angles, which means 5 + 6 has to be 180. So that's another thing we know about this figure. 5 + 6 has to be 180. What else do we know? Jitsia, any other things we know? So we can use that same concept with 5 and 6 and apply that to other angles, right? We could say same thing with 3 and 4. They're adjacent to each other, right next to each other. We can draw a semicircle, meaning basically they are on that same line, which is 180 degrees. So 3 + 4, well, 3 + 4 would also have to be 180. Christian, can you tell me anything else? I don't know that we'll get the last one, but and there's other ones too. But can you tell me anything else? So we just said, the last thing we just said is 3 + 4 has to be 180 because they are adjacent to each other. We can draw a little semicircle through them, which means that's 180 degrees. Well, then that means 4 + 3 has to equal 180 degrees. Anything else that you can tell us? There's one new thing we learned. There are actually some other things you could say that we sort of already said, but. And 6 or not. If we had parallel lines, then yes, but this line here is not parallel to this line here. If it was, then we would say yes, but then we also wouldn't have a triangle because if they were parallel, they'd have this. Do you remember the last, or not last, but the last new one really?
You can use angles 1 and 2 to find the measure of angle 3 if angle 3 is missing.
Well, that's the concept of them adding up to 180, but yeah, if you're missing one angle, I thought you were gonna actually say the other one.
No.
You can use the angle measures of 4 and 6 since they are on the same, well, either one of them is on a line that angle 3 is using, so if you just subtract them from what that measures of each one other angle to be 4, and if you subtract 4 from 180, you can get the missing angle measure for angle 3.
So anything that we've said, I mean, you're doing the math, but that's using the principle. There's one new principle we haven't mentioned. You're just now using the principles to do some math.
Oh.
So, because you're using either linear pairs, meaning they're next to each other, or the fact that 1, 2, and 3 equals 180, and you're just doing the math using those, but there's one sort of new one that we haven't mentioned. Remember it?
The hour, like, hour, like you said,
Well, you can use the
Like,
numbers of
remember
the
that.
angles.
the
That's why I
2
wrote it.
plus something on the hour side, if you extended the line. And then it would equal working for the, what's it called? So offset the interior angle.
So that's one we haven't, so we haven't named anything. These are interior angles. Well, maybe I did say interior. Don't forget, we have exterior angles also. Angle 4 is an exterior angle. It's outside the triangle. Angle 6 is also an exterior angle. It's outside the triangle. So you do need to understand that there's an interior angle and an exterior angle. But there's something about the interior angles and exterior angles we learned. This one's a little tricky here. Know the answer, or are you asking that? Not just yet. Not until I finish this last piece in the notes. Anybody can get it, and I'm just gonna tell you we need to.
Is it if you at the exterior, the interior angle and the exterior angle add up to 360?
The sum of the exterior angles does add up to 360, but we didn't actually learn that. I should have probably taught that, but I mean, again, you can normally figure out any problem without knowing that specific. I guess I'll mention that. I didn't go over that. If you add up now, I can't use this figure, so let me finish the last one and then I'll do a different figure because I have two exterior angles written in here and they're on the same angle and you can't use them twice. So I'll do a new figure and I'll show you what I just said, just so you know. I'm not gonna quiz on it, but maybe the district will make something where that you have to know that. We said the other thing, and I told you initially that you didn't need to know this because you could always figure it out using other information. Well, then they gave you a problem number 34, which I'm going to put up on the screen. And you did have to know this in problem number 34. If we have an exterior angle, so 4 is exterior, it's outside the triangle. We said the exterior angle is equal to the sum of the two opposite interior angles. So 1 plus 2, the measures of 1 plus 2, I don't literally mean the number 1 plus the number 2. It's the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Yeah, but both of you, I think, were kind of around that concept, like hitting pretty close to it. But this is what you, I guess, apparently may have to know sometimes. In most problems, you can figure it out without knowing that. You can solve for, say, if I knew this one, I could solve for 3. Then if I knew 3, I can normally figure it out because those 3 have to add up to 180. But they gave you a problem where you couldn't figure that out. So I'm going to go over that problem separately. Really quickly, let me just show you what I was talking about with exterior angles. So if you have a triangle, and I just messed it up, but that's fine. If you take, so again, exterior angles, you have to think about always going. So I'm going to the right. I'm extending that side to the right, which means I have to keep extending all the sides out to the right. You may think I just extended to the left, but you have to think that I'm going from here to the right, and then I go from here. You have to look at it from a different angle. So now I've extended all the sides out in only one direction. It's kind of like a rotation sort of concept that I'm going around. I'm going this way and then that way and then that way. This exterior angle plus this exterior angle plus this exterior angle will add up to 360 degrees. So the interior angles add up to 180. So I would write that note down just in case. I don't think I will use it. It depends on how often it pops up in problems. Because they didn't even really mention it, I don't think, in the book. I don't remember seeing it unless they're going to mention it later. But exterior angles add up to 360. And there's a proof behind it if you wanted to do a proof to figure that out. All right, so let's go ahead. Any questions on anything that we just went over? Like those concepts that we just did on the last screen, that's pretty much everything you're gonna have to know for the quiz on this particular topic. There's gonna be probably 2 grades again this week. One on this and then one on what we're doing next, which is called congruence in triangles. You can go ahead and trade your phone out. So here's the problem, just really quickly. I'm not going to solve it out. This is the one where you did have to understand that the exterior angle adds up to 2 interior angles. Otherwise, you could say, normally, you could say, okay, well, these 2 need to add up to 180, and you could say they add up to 180. Problem is, I have 2 variables in that one equation, so I can't solve that. I can't add these 2 up. Like I could solve for this and I could get a number here, but adding these 3 up here, so this one, whatever that number is, plus that, adding those up to 180, again, I have 2 variables. I can't solve that equation. So the only way to solve this particular problem was to understand that this exterior angle has to equal. Actually, that's wrong too. I did it backward. I mean, it's still the right concept. You have to solve for this. So 45, it's the other way around. And then you say this exterior angle has to equal the sum of those exterior angles. Now you have one variable, one equation. So the only way to do that one was to remember that
Wait,
concept.
so the 135, what's that supposed to do? The 45 on this side?
Yeah, because the reason they give you this is so you can get this. And now that you have this, you can say these 2 interior angles
You got,
add up to the exterior.
oh,
Because they're the opposite, right? They're
Yeah.
on the opposite side. Javiel, off your phone, earbuds out, put your head down. If you want to say it, otherwise you can listen. I don't know what they let you do in IC, but we're so again, I will let you know now. We're at that point right now. Anything that happens, you're gone. Anything. So if you want to stay in here, do exactly what I just said. And this is probably going to be bad for you because there's no way you're going to be able to resist, I'm sure, in saying something. But you're right now, anything that happens, you're gone. I'm letting you know that explicitly. All right, so now let's go ahead. I'm not going to solve that out, but you would solve for y. Once you solve for y, then you can go ahead and solve for everything else. Look at your book pages. Turn to, I don't remember the page. You're looking for this figure though. Whatever's right after triangles. I don't know the page. I mean, I have it up. I can, if you can't find it, I can pull it up for you, but I'm assuming you're big boys and big girls, you can find that figure.
I'm a little kid.
Trust me, I wonder sometimes. Really wonder. It's right after
Yeah.
triangle.
I think
So somewhere around page 280-ish.
page
it's-
281.
281, there you go. Page 281.
Always good.
I'm doing this super fast. I don't think we'll wind up getting to the next lesson, but
Just try. Which is right.
told you the next thing was, that was the. You're disruptive every single, I don't know. Very explicit. One more, I said, put your head down.
Look at me.
I said, put.
I told her to turn around.
Okay. Again, I said one thing. That means you need to just be quiet. Don't say another word to anyone. I mean, I heard you talking to him, heard it all, but try to ignore it, but eventually when you start disrupting people, I can't. Said, you don't work, I'm fine with it. Put your head down, sleep. You disrupt people, you're gone. Every single time.
They were first to go through Michigan.
With just him or other people?
It's
about the same
a
number.
week.
It's about the same number. It is crazy. It is crazy. Can you send me somebody, to escrow students license? C3.
And you saw them.
Thank you. When I get to that point, it means zero noise on you. I told you that. I said, put your head down. That's the only way you're gonna make it. It doesn't matter. Zero. That's why I don't say keep it at a 1 or a 2. That's why I say zero you, because that's the only thing I thought you could understand. Because I'm not gonna have you disrupt other people. I don't care if you don't. Really don't. Don't disrupt other people. And that's what you're doing. That's why you get kicked out every single time. It's not you. It's when you start to disrupt other people. All right. So quickly now, very, very quickly, I am recording. Oh, that's on. So when you have a figure that has congruence marks, if the two figures are congruent to each other, that means there is a side that matches up on the other figure, like for every single angle, every single side, everything. So if you'll notice, all the different sides are a different length for that figure. That's why there's a 1, 2, 3, and 4. All the angles are different. 1, 2, 3, 4. Nothing is the same. No sides are the same length within one figure. Then the other figure is a congruent figure. If I took this and if I flipped it, or if I rotated, or if I slid it over there, this figure would land exactly on top of that figure. It would match up perfectly. You would only see one image there because it'd be right on top of the other one. That's what the definition of congruence is, that we can take this and somehow map it exactly on top of that. We did rotations, translations, reflections. That's what that was all about, is determining congruence. They are the same image. The next important thing to note is that when you name them, they are in order. The A angle will match up with the W angle. You can look up there just to confirm that. A has 1 tick mark, W has 1 tick mark.
Does it have to be lowest tick mark to highest tick mark, or?
No, the number of tick marks. I mean, normally it will be,
Yeah.
but that's not,
Right.
at least in my opinion, as long as they are congruent to each other, that's all that really matters. You probably will always see the first one be 1 tick mark, then 2, then 3, then 4 in that order. This is going to mostly be in triangles where you're going to see this stuff. We won't deal a lot with 4-sided figures. It'll mostly be triangles. But if you'll notice, A is congruent to W, B is congruent to X, C is congruent to Y, and D is congruent to Z. So you also have to know when you name a figure. If, like, they ask you to name these two figures yourself and they give you these letters and where the tick marks are, you need to make sure you write them in the correct order or else it's wrong. Don't know that I'll quiz you on that, but there could be something on the district where all you have to do is name figures or understand how the naming works. And it just goes based on what angles are congruent to each other. And they won't put one like you're talking about where it would be, different number of tick marks in a different order. You have 1 tick mark matched up with 1, you're good.
No,
The sides are also congruent. So when you name it, you'll notice that side BC is the 2 middle letters. It has to be congruent with XY. So you'll see that XY is there. So not only do the angles match up based on the order of the letters, the sides do. So side AB is congruent to side WX. There you go, side AB, WX. So the angles and the sides have got to match up and be in the same order. And that's how you know, even if you don't have tick marks, like they don't even really need, if they tell you the figures are congruent, they don't even really need the tick marks anymore. because you should just know that angle A is congruent to angle W, B is congruent to X, C is congruent to Y, D is congruent to Z. So keep that in mind. You may not always have all these markings. They may just tell you this, and it may be triangles, it could be other figures. Normally triangles is what we'll deal with. You need to understand that if they don't have all those markings, but they tell you that the two figures are congruent, then you need to be able to match up which angles are congruent to each other based on the order of the letters, or which sides are congruent to each other based on the order of the letters. Any questions on any of that? I'm not spending a bunch of time on that. It is crucial to understanding every problem that we do, though, the math behind it. Wait, I thought I put, all right, so go ahead, go to your first page. Why am I still hearing stuff out of you?
My first page after like. Bring me my first page.
So I want you to do that check problem right there. All right, go, just go. Go to Peppers. Yeah. Yeah, I know you're on the way. I did last time.
Which page is
We had a conversation. I'll do that whole time, so we'd be thrilled to see that you're coming in again, I'm sure.
Which page is it?
This page is 282. So I want you to do the top of 282. Just complete that check section.
You heard that?
So I'm gonna move you because I want you up front. You're gonna move. I know he's the issue, but I still feel like that's gonna be good for you. So. Page 282, you're filling in the blanks right there. Yeah, he hasn't come back in a while and we're running out of time for you to be able to go if he finally gets back. Right. Oh, hey, just in time. Just in time. We're ready to pull out one for you too.
Job here.
Hmm?
Well, he did.
Same thing he always does.
Are you? Pretty obvious.
We're doing this, I mean, you kind of missed the whole lesson, but we're doing that problem right there at the top. Page 282 at the top. If you want to try to do example 2 after that, you should really be able, I mean, they tell you really what you're doing.
Yeah, it's like that. Let's go for a two checker.
Oh,
It's they have to be a third line, like.
What's that?
there are three tick marks for four lines, so should be two based on the.
I think there's 4 between Q and R, right?
Like, zoom into.
I don't think I can zoom in anymore.
Oh, it's freeze. It's freeze.
Well, oh, okay, hold on. Maybe I did zoom in and it just didn't show up. Oh, there you go. Okay, so what's your question? Well, that means they have the same measure.
But like, if you rotated them, they wouldn't have the same measure, and also. they're-
Well, if it has 3 tick now, maybe it's a typo. But if it says 3 tick marks, then they're saying that so don't count on it being drawn to scale. So a lot of times they will draw it out of scale on purpose because they want you to understand how the markings work. They don't want you to be able to just look at it and tell which ones are the same, which ones are different. So I would go based on the assumption that the markings are the correct thing. And if you do that, I'm going to go over how to know which one of those corresponds to which one's in the other figure. Because I think that's what they're trying to let you know is, well, if these are the same within a figure, how do I know which ones they match up with there? That's what they're trying to get you to understand. And you can probably figure out how you would know that, I would bet. But I'm going to go over it. So I'll give you another minute to finish that one up. This is actually a very crucial concept also. In addition, this is kind of like the next level of difficulty. Like if all the markings are different, that's pretty easy. But when you have some of the markings the same within one figure, how do you tell which ones they match up with?
Not that difficult. It might get hard when the angles, they start right, or the lines
Let's see,
start
I'm
racking
gonna
up.
let you tell us all the answers. I mean, I don't think it is. It's logical. Like if you use logic, then that will probably get you the right answer, but sometimes people don't think about it. They just write something down based on something else about the way they figure. Some of them are pretty easy, so we're gonna start with the easiest ones. It asks us, P is congruent to. Well, P has one marking in it. So what's P congruent to? You just say it out loud.
G.
G. So again, I look at where angle P is. That only has one marking. It's the only one with only one marking. So that makes it pretty easy. There's only one with one marking then down here. So the answer is G. So that's not a 6, that's a G. So that one's not too bad. What about angle? Actually, none of the angles are really bad. What about angle Q? So again, angle 2 has 2 markings. There's only one with 2 markings. I'm just going to write the letters in. I'm not going to write the angle symbol. What about R? 3 markings. So you find the one with 3. Well, 1, 2, 3. And that should leave the last angle, but let's just make sure. S has 4. Which one has 4? Yep, sure enough, the only one we haven't used. So angles were pretty easy in that. They all had a different measure. That always makes it. Now, oh, I had to send him out. He was skills disruption. So I sent him to Peppers. What do you think? How are you? So now it's gonna get a little trickier. The first two are, I'm assuming they'll go in order, probably easy. PQ, so that's from P to Q, only has one marking. It's the only one with one marking. So what is it congruent to? Make sure you put G first.
At the start of.
Technically, you could make an argument that you could write F first, but we want to match up the angle that has one tick mark and make sure we keep it as the first one. Like I said, I probably wouldn't do that right. Yeah, GF. So I probably wouldn't mark it wrong, but just in case. QR has, so now it's going to get a little tougher. QR has 3 tick marks. Actually, tell you what, let's do PS or SP. Let's do that one next because it's the only one with 2. What does SP match up with?
PG.
Yeah, it's got 2 tick marks. Only one of them has 2. I'm going to start with the letter, yeah, that has 4. D has 4. Oh, DG. Again, 2 tick marks, 2 tick marks. So that's why I'm matching those up. Because they both have the 2 tick marks. That tells us those lengths are the same. All right, now let's do the ones that are a little tricky. So I have QR. It's got 3. But when I look down here, there's 2 of them with 3. So I got to figure out which one it matches up with. What do you think? So Neo, here's where you said it was easy. What's the strategy, Neo?
That's a deep. On the.
But
The
what,
same.
but what?
But how would you know that?
That's, that,
I think it may know.
the angle that happens to like the 2 and the R
Big
are 3. If that's.
So we look at what the angles are around it, correct? So if I have an angle with 2 tick marks and an angle with 3 tick marks, I need to match that up with the angle with 2. This one is 4 tick marks and 3. That's not the right side. It has to be the one with 3 and 2. And it doesn't really matter which one's on the right or left, because remember, we could be flipping it over. So don't worry about the fact that one's on the left or the right. You just need to find the 2 markings that match up with the 2 markings up there for the angles. So like if you look, you may say, but wait a minute. Here, the 2 markings are on the right, the 3 markings are on the left, and down here it's the opposite. Just means the figure is flipped. It's still the same size. That side is still the correct side. Just means it's flipped in one image. So don't worry about which side it's on, worry about what it's between, basically. So it's between the 2 and the 3. This one's between the 2 and the 3. So, and we would, what was Q was first. So Q had 2 in it. So we'd say FE. So now for RS, I mean, it's the only side that's left really. So we really could just use that, but we'll go ahead and look at it. So RS, I can do this. There we go. So RS is here, so it's got 3, so I definitely need to use the 3. It goes from 3 tick marks to 4, so it needs to be the one that's between the 3 and the 4. It doesn't have to start at 3. So between the 3 and the 4 is this ED. I'm still going to go ahead and start with the one that had 3, so E. D. There probably will be a question like that on the quiz, naming something like that. That's pretty, I'd say pretty similar to that one, where I give you markings that are the same somewhere in the figure, and then you got to figure out how that corresponds to the other figure. And again, this would be just in the same order. P, Q, R, S would match up to G, F, E, D. So G, F, E, D, same order actually. G, F, E, D would be that polygon. Any questions on that? All right. Let's maybe the last thing we do this and then the check. It's a pretty good one to end on though.
Alright, let's try to find. Yeah.
So yeah, using the, remember, this is the order they match up in. R matches up with T, S matches up with V, V matches up with, I'm sorry. Oh. Oh yeah, because V, oh, so this one's a little trickier. V has 2 angles, 1 in each. So that's makes it a little trickier. So I want you to try it.
All harder than.
We're not done, so don't pack up. Oh yeah, we're not even close to it. We got 57. So go ahead. I mean, they kind of did it for you, but.
Just.
Well, the main thing is I mean, it's pretty easy to match up this super skinny angle. You know, there's only one other super skinny angle. So if you know they're congruent triangles, that one's easy to match up. From there, you have to figure out which angles match up with. Sometimes angle V will match up with angle V automatically because there's only one angle.
Single.
Like, for example, side SV is always going to match up with side SV because they share that side. So it's got to be congruent to itself. If they share a side or if they share an angle, then that angle is going to match up with itself.
Yeah.
Or that side is going to match up with itself.
Yeah, the angle measures, really, I just have to solve for variables.
Well, right now I'm just trying to get you to match up the correct angle with the correct angle. So just like tell me CPCTC. Oh, this is the one that the other teacher always says. CPCTC.
It's easy for, it's, see, but shouldn't be that one.
I mean, I would say this is,
I mean, I'm speaking.
it's not a high difficulty level, but it's about average difficulty level. I'm not going to get, now I don't know what the district is going to do on their midterm, but I'm not going to get way more complex than this probably. Pretty similar to this, I would say, kind of like the figure up above. When I give you a problem on naming, it'll be pretty similar to the one up above. I don't know what IXL will do. I try to take some problems that match up with the book problems, because that's what we did the lesson on, and then some problems that match up with IXL. That way, if you truly practice both, you pay attention during the lesson, and if you practice, you should be good. I haven't even assigned the IXLs yet. We'll do that tomorrow. We'll do a new lesson, and then you'll practice both lessons. All right, so let's go ahead and start moving forward again. T and R matching up is, I mean, that's a pretty easy one in this figure. If you get a figure where it's that obvious that the super skinny angle is the only skinny angle, then you can go ahead and say, yeah, T's got to be congruent to R. Plus, that's the order that they name it. So R has to be congruent to T. Now, it's a little weird because you might think, well, wait a minute. How is it that V is not the same angle with V? Well, they're different measures. This V angle here is 78 degrees. What's this other V angle?
It's 90.
That one's 90 degrees, right? And again, the only
Yeah,
reason
that's
Because
you might know that is because of the shape of the figure, really, but
Baker Street did that.
but it also does match up with S. So if S is 90, then V. Oh. Oh, I'm sorry, I was looking at the wrong time. No, I was looking at the wrong time. I was thinking this was third period. All right, so we'll start there then. So I totally got wrong. Well, I need you up front because
It's
you're
nice
last
up
quiz.
front. Copy it.
There's,
There's no
even if
copy
you're
out.
back there without him, if he wasn't even existing, I still feel like you're gonna struggle with focus. I look up sometimes when he's not here and you're just going down.
I think
So
that's
up here, I can keep an eye on you faster and I'll notice that. Sometimes I don't notice. But if I keep you up here, it'll remind me to make sure you're staying focused. I didn't grade any, I mean, I graded retakes. I can show you what you got on it if you want to see. But I didn't put it in the book.
Have a good day.
All right, see ya. Where are those?
Kristen,
Hey,
keep it.
you did the surface area one? All right, man, I'll see you in 2 days. Oh, no,
In
see
2
you guys tomorrow.
Yeah.
Oh, you're right. Yes, 70, so you were good on these two, but this one, I didn't give you what you needed. 10 wasn't the number you needed. If you look at the formula says the regular height. I gave you the slant. You had to solve, that was the A squared, B squared, C squared thing.
Was confused.
So, yeah, and unfortunately, that was the last day for that one, so. I mean, 70 is not gonna kill you. So just make sure you do well on the one this week, and then if you didn't do well, one we just took. Well, no, the one we just took last week. Is that, oh, distance, so there was 2 grades, distance between a point and a line and transversals and parallel lines. So those are the ones you can retake now. I think you probably did pretty well on one of the parts of it, but then not on the other part. So you definitely want to retake that. Right? And I should have this updated by the end of the day, so after school. For that.